Hi and welcome to a new video. Alright, in this video I'm going to talk to you about indices and logarithmic functions. So, what is a logarithmic function? So, logarithmic functions are just, these. Um, but so logarithmic functions are basically just indices, but written in a new way, as a function, a new function. And you can actually use logarithmic in your calculator as a quick way to find an exponent like that, so an index number. So let's go over with this. N equals to a to the power of x. We can rewrite it as logarithm of the base a that results in n equals to x. So this is really useful because before you have something like 3 to the power of x equals to 9. You can then rewrite it as 3 squared equals to 3x, so therefore x equals to 2, right? But some functions like this, some equation like this, 10 to the x equals to 200, you don't really have a rational answer. So 10 to the power of x that results in 200 can't really be calculated with normal algebra. So you're gonna have to use your calculator, plug in this logarithm of base 10 200, and it will show you that it will be approximately 2.301. Now logarithm of base 10 usually will be written as log, just log. It's not going to be as base 10 because mathematicians want to make it a little bit quicker. And logarithm as base 10 on your calculator is most likely not going to be shown as base 10. It's just going to be shown as log. So yeah. Now, what if you have this, equation right here that you want to solve for x? You clearly can transfer it into a logarithmic function like that. 200 equals x. But then your calculator don't have that button. If some of your calculators do, then lucky for you, but your calculator don't have a button right there to put log of base 3. So how are you going to solve it? Well, a way that you can solve it is that you can take the log of both sides. Now, which brings me to logarithms as a way to to divide, subtract, multiply, and add. It's basically like an operation. Logarithm is an operation as well. So you can take a log of both sides with base 10, of course, and you get that. Which brings me to a new rule right here that I'm going to show you guys later. But so which equals to that x log 10, x times log 10. That results in 3, and then log 10, blah blah blah, and then we can say, and then we can plug it into a calculator to find x equals to log 10 over 200. So that's a way that you can find x without having to put the base in your calculator. Now I'm going to show you guys a couple of rules, logarithmic rules and laws, just 3 laws that you guys need to know. So the first law is the addition law. So log to the base a that results in m plus log to the base a that results in n is going to be equals to log to the base a mn. Now another one is log to the base a that results in n minus log to the base a equals to n. Results in n. Results in n is going to be equals to log a m over n. Pretty easy, huh? Anyways, now the last logarithm, which is really useful for the stuff that I just said, is this law right here, log to the base a, where m to the n is going to be equals to n times log base a m. So those are the three laws you need to know. Now let's go to a practice question that most people can do. One practice question. So how are you going to solve log to base 4 that results in 400, let's say 400. Even though you can clearly easily solve this using normal indices, but let's solve it using logs. So first way you can solve it is that you can plug into your calculator if you have a calculator with like that. If your calculator allows you to do that. But another way you can do is that you can do log, take the log of both sides, and then you will get x log 10 4. Okay, and then you can divide that by that and you will get the answer. Okay, now what about turning logs into normal? How do we calculate some log functions using our brain without our calculator? So in a test you probably will have to do this, but in real life situation you probably won't. So let's say you have log that result, with base, 2, that results in 4, okay, equals to x. Now how do we solve this? Without, using calculators, of course. So it'll just be 2 to x equals to 4, which means 2 to the x, that is 2 squared, and then x equals to 2. So therefore, x equals to 2. Another one can be log with base 5, results in 625. Base 5, that results in x, I guess. Oh no, let's say it results in 1625. Okay, how do we solve for that? We don't have a calculator. How do we solve for that? Well, you can just use normal indices laws, 25, and we know that that's just going to be 1 over 5, 4, which is 5 to the negative 4, and therefore x equals to negative 4.